We will be looking at a 3-point genetic map using narwhals. And so we have 3 traits in this case. One, which is tusk length, where the long tusk is dominant to short. And we have skin spotting, where spotted skin is dominant to non-spotted. And then we have head shape, where rounded head is dominant to pointy. And so here we have the map of a heterozygous individual where the distance between the first and second loci is 12 centimorgans, and the distance between the second and third is 10 centimorgans. Our coefficient of coincidence is 0.8. To achieve this individual, we needed a cross between a purebred homozygous dominant and a purebred homozygous recessive individual, and so that is someone who is homozygous for long tusk, spotted skin, and round head, mating with an individual who is homozygous for short tusk, non-spotted skin, and a pointy head. So here are the 4 types of gametes that the heterozygous individual can produce. Double crossover type, single crossover type at the first position, single crossover type at the second position, and a non-crossover, which is also just known as the parental type. And so here are the gametes produced by each, and here are the probabilities of each occurring. If we are looking at single crossovers at the first position only, let's say for instance we are looking for the probability of long tusk, non-spotted, pointy-headed gamete being produced, and so I'll represent that here. The probability of this occurring would be the distance at the first position minus the probability of a double crossover event times 1/2. And that's done because there are 2 types of single crossover events at the first position, and we only want one of them. And so that probability is 0.0552. If we look at a double crossover event, so let's say we want a short tusk, spotted, pointy-headed gamete, so that would be represented by that. This probability would be calculated by finding the probability of a double crossover event, which would be the distance at the first position times the distance at the second position times the coefficient of coincidence. And then again, there are 2 different gametes that can be produced by a double crossover, and we only want one of them. So we need to then multiply that by 1/2 to get your final probability of 0.0048.